All right, so here's where we put it all together. So this activity is called exponent experimentation. So here we are working with exponents and variables together. So the instructions tell us that we need to find a solution to each equation. So a solution, all that means is a value for a variable. So a number that we're going to assign a variable that makes an equation true. So we're finding a solution to each equation. So for each of these, basically we are trying to find the correct value for our variable that will make it true. So once again, to go back to what we've been doing since the beginning of the week, reasoning with variables is a lot easier if we're always actually thinking about what we're looking at, right? So it's one thing to know that we just use inverse operations to solve for the value of a variable, but if we actually can like put what we're looking at into words, it becomes a lot easier to solve. So we're seeing x, some number squared is 64. So once again, if we wanted to write that as a sentence, we replace the variable with the word what. So we could say what squared, or we also know that an exponent is a number times itself. So what times itself is 64. Because the thing is here, we don't actually know the inverse of squaring things or cubing things yet. So this is really our only way to reason with this kind of problem. So what times itself is 64? Well, we should all know, if we know our times table, then we know 8 times itself is 64. And then it's always just good habits to show that substitution of you checking your work. So I'm going to replace x with 8. And if I rewrote that in expanded form, that would be 8 times 8, and 8 times 8 is in fact 64, so it works. So once again, this translating an equation into a sentence can really help us reason with a given problem. So number 2 looks awfully similar to number 1. There's just one difference. The exponent, instead of it being squared or to the second power, it is cubed or to the third power. So that's going to be what times itself, not just what times itself, that's squared, but what times itself 3 times is 64. And I know that we don't know our cubes off the top of our head, so we can just kind of guess and check. So let's start with 2, okay? 2 times 2 times 2, 2 times 2 is 4, times 2 is 8. Definitely got to be bigger than that. 3 times 3 is 9, times 3 is 27. And 4 times 4 times 4, 4 times 4 is 16. 16 times 4 is 64. So that's the one. So what times itself 3 times is 64? That would be our value for x, 4. Once again, we substituted that in. And we did 4 times 4 times 4, that expanded form, 16, and then multiplied 16 by one more 4. We would see that both sides of our equal sign are equivalent, so it works. Okay. Now, so the next one, a little bit different, right? So now our missing value, our variable, it is the exponent. So try and think what that would be as a sentence. If you want to take a second, you can pause and try and write your sentence yourself. Okay? So this sentence would be 2 times itself. We don't know how many times. So 2 times itself, how many times is 32? 2 times itself, how many times is 32? So once again, I'm sure that we don't all know this off the top of our heads, but we can reason with this problem by, guessing and checking. So 2 times 2 is 4, so not squared. 2 times 2 times 2, times 2 is 4, times 2 is 8, times 1 more 2 is 16, times 1 more 2 is 32. So 2 to what power? How many 2's do I have? 1, 2, 3, 4, 5. So x must be 5. So that is my value, that is my solution, because 2 to the 5th power, as we just saw, was 32, so it checks out. All right. Now, number 4, this one you don't even really need to write a sentence, because now the nice thing about number 4 is that x is already isolated, meaning that x is on its own side of the equal sign totally alone. So all we have to do, we don't have to do any kind of like mental gymnastics of thinking about the situation that much in depth, because we just have to do this work. So like, what is 2 to the 5th times itself 3 times? Right? When x is already isolated, then you just do exactly what it tells you to. You don't have to do inverse operations or anything like that. So 2 to the 5th times 2 to the 5th times 2 to the 5th. Once again, you're multiplying fractions. Your numerators multiply. 2 times 2 is 4, times 2 is 8. And then my denominators need to multiply times each other. 5 times 5 is 25. 25 times 5 is 125. So x would have to be 8 125ths. And that checks out. And if we wanted, we did have a list of potential answers. And we saw that that was a possibility. Just because, you know, sometimes you get an answer like that giant fraction, and it looks kind of strange, and you kind of like question yourself if you got it right. Luckily, in that list, we can see that that was the solution. That was the right value. All right, and so there was one more page to this. So now we're beginning to work with a little bit more fractions and things of that nature. So 16 over 9 is equivalent to what times itself? So what times itself is 16 over 9. So I know that seems really stressful. You know, fractions, exponents, variables. But remember, fractions and exponents really aren't that stressful because they function just like whole numbers do. So we can say what times itself is 16. Well, 4 times itself is 16. And what times itself is 9? 3 times itself is 9. So x has to be 4/3. And then if we wanted to check our work on that by substituting our value in, to rewrite that in expanded form, 4/3 times itself 2 times. Once again, we can see that if we did that, 4 times 4 is 16, 3 times 3 is 9. Just knowing that rule that when you multiply fractions, numerators multiply together, denominators multiply together. All right. So this one, 2 times 2 to the 5th power equals 2 to the what power? Okay. So we already know that for this one, let's do this one a little bit different. Okay, so we already have this 1, 2, the one out in front, and then we're going to take that exponent to the second one, the 2 to the 5th, and we're going to write that in expanded form. So that's 5 2's, 1, 2, 3, 1, 2, 3, 4, 5. Okay, so 2 times 2 to the 5th power could also be written as 6 2's, and 2 times itself, 6 times, is 2 to the 6th power. So 2 times 2 to the 5th power is 2 to the what power? 2 to the 6th power. So x equals 6. Okay. This one's interesting. So 2 times what is equivalent to 2 to the 4th power? So first, we should probably figure out what 2 to the 4th power is. 2 times 2. This is 4. This is 4. So this is 16. All right, so 2 times what is equal to 2 to the 4th power, which we just found out is the same thing as 16. So 2 times what is equal to 16? X has got to be 8, right? 2 times 8 is 16, or 2 to the 4th power. Once again, we want to check our work, so we just found out that 2 to the 4th power is 16, so I can just leave that as that. Substitute in this 8 in here, and let's see if it checks out. It does indeed, so X, my value there is 8. Alright, and 4 to the 3rd power is the same thing as 8 to what power? So once again, before we even write our sentence, since we don't know what 4 to the 3rd power is off the top of our heads, we should solve that first. 4 times 4 is 16, times 4 is 64. Okay, so this makes it a little bit easier now. So 8 times itself, how many times is 64? Right, because we just found out 4 to the 3rd is 64. So instead of saying 8 times itself, how many times is 4 to the 3rd, we're going to say 8 times itself, how many times is 64? And 64 and 8, that should be, light should be going off in your brain, because you know 8 times itself, 2 times, 8 times 8 is 64. So then X must be 2. So if we substituted that in, so instead of having that X there, we're going to place in this value to check our work. And if we rewrote that in expanded form, that would be 8 times 8, which we know is in fact 64, so it checks out. Alright, so at this point you're going to be moving on to your practice problems and exit ticket, so good luck.